So we were talking before that we have this timeline. There's our timeline. So again, 1400, 1500, 1600, 1700, and moving on from there. Reformation starts 1517 right here with Martin Luther. Okay, so that's where the Reformation begins. Luther nails his 95 Theses to the church door, starts fracturing the power of the Catholic Church, starts breaking up the church's ability to control and to govern all parts of life. I want to go back to a point we made before about the about the Protestant Reformation and why this is so important. Virtually everybody in Europe in 1517 is Catholic. Well up into the 97% range is Catholic. There's a very, very small number of Jews, very, very small number of Muslims in Europe, but the vast majority are Catholic. One sec, sorry, the phone is ringing. I'll be right back. I'm back. Sorry about that. Okay. Can't read the board. Where's Gareth going? Okay, it's okay, Taylor. You don't need to read the board so much. I'm going to put some darker colors on there too here in a second. But what was I saying? Oh, Catholic Church. Here we go. The Catholic Church is the religious entity, okay, or Catholicism is the religious entity in Europe in 1500. 1500, is that easier to read? 150. We'll see. This is not great, perfect technology. We're doing our best. Protestant Reformation starts 1500, right there, okay? And from there, what you start to have then is you start to have all these other things that come off from there. As the Protestant groups start to create their own different religions, they all start to create their own different interpretations of Christianity. And that's where we have Elizabeth and we have everything else. We talked about in 1648, 1618, okay, 1618 to 1648 right there. This is the 30 Years' War. And the 30 Years' War is this war between Protestants and Catholics over the interpretation of religion. And that's really what Martin Luther's Protestant Reformation is a attack on the interpretation of Christianity by the Catholic Church. The Catholic Church is saying as a part of their dogma, which is, and dogma is a word which means the way in which you enact your religious beliefs. So one of the biggest differences, for example, between Protestants and Catholics is not the faith. They believe in the same God. They believe in the same 10 Commandments. They believe in the same religious events and so on. But the way in which they celebrate those events, or the way in which they pray, or the way in which their church services go are different. That difference is what's called dogma. So it's the interpretation of the religion, not the religion itself. It'd be the same thing between Shiite and Sunni Muslims. The difference is not the religion. The difference is the interpretation of that and how it is that your practices go, and so on. Ashkenazi Jews versus Hasidic Jews and so on. Same sort of idea. We're interpreting it differently, and that's the big difference. Religion's the same, interpretations are different. Well, as part of all of this, when the Protestant Reformation begins, people begin to flee the Catholic Church because what Martin Luther is saying is that you don't have to pay to go to heaven. Catholic Church is charging it. You don't need to do that because of the system of indulgences. People begin to flee. They begin to go away from Christianity. So the Catholic Church in the 1530s begins a thing called the Counter-Reformation. The Counter-Reformation is, as the word implies, trying to stop the impact of the Reformation on the church. People are fleeing the church in droves, in the millions. They're leaving the Catholic Church because the church is charging them money. The Catholic Church has to reform itself. So rather than letting the Protestants set the pace, the Catholic Church decides they are going to set the pace. So starting in the 1530s, starting back here, so the Reformation begins right there. Right there, you have what's called the Counter-Reformation, which is the Catholic Church picking up on the clues. Okay, so they're picking up what the Protestants are setting down, saying that there's a problem with the church, we need to fix it. They begin to fix the church in a lot of different ways. So I talked to you before about the fact that bishops and cardinals weren't necessarily religious people. They had purchased their rank in the church. That's gone. Catholic Church gets rid of that. Catholic Church also says that you have to live in the diocese where you are supposed to be. For example, in the 1400s, there was a Cardinal of Cologne. Cologne is a city in Germany, K-O-L-N, or if you anglicize it, C-O-L-O-G-N-E, like Cologne. There was a cardinal that was supposed to be in Cologne because there's the Dome Cathedral is there. That's where his cathedral seat was. That particular cardinal in the 1400s was only ever in Cologne twice. Thanks, Gary. Twice. Once for his inauguration as the Cardinal of Cologne, and once for his funeral when he died. The rest of his time, 20 some odd years, he was not in Cologne. He was in Rome. And why was he in Rome? Because that's where the power is, and this guy wanted to become the next pope. You can't become the pope if you're in northern Germany. You got to be down in Rome where all the big things are happening. So again, that's clearly a problem. So the Catholic Church changes that, says you've got to live where your job is. You've got to actually be trained. So they create seminaries and so on to train priests and train bishops and train cardinals. You can't buy your role anymore. They don't charge for indulgences anymore. So salvation is now free and so on. But there's one other big change that happens as part of the Counter-Reformation. And this is the only reason I drew the timeline on there back there, because we've now moved on in our course, but we're going right back again to the start of our course. There's one big change that happens right here, right in the middle of the 1500s. One big change that happens. The Catholic Church feels the need to reform the calendar. So there is a calendar that has been in existence since the Council of Nicaea. If you remember, going back to day 2, we talked about the Council of Nicaea. That's when the Emperor Charlemagne says, okay, all you Christians get together, figure out what it is we believe. So they come up with the Nicene Creed. They come up with Mary was ever virgin and Jesus was died for 3 days and was reborn, all that stuff. The tenets of Christianity are established by the Council of Nicaea in and around 330 CE. Council of Nicaea, at that point in time, also says we're in the year 330 in the new calendar we're going to use as Christians as part of the Roman Empire, because the old Roman calendar was different than the calendar that they were using at this point. So that's when they established a 7-day week, and they make that permanent. That's when they established the 12 months that they've got. Now the months were started, we're getting off topic, but those months were started by earlier Roman emperors. So the July is named after Julius Caesar, and August is named after Augustus Caesar, etc. But they cement the 7-day week with January, February, March, April, May, June, July, et cetera, and so on in there. And they cement this calendar. And that calendar is called the Gregorian calendar. This is the old calendar from the 300s. The Gregorian calendar is established that way because the Pope at the time was a guy named Pope Gregory. So it worked out well. The Gregorian calendar is established, but the problem with the Gregorian calendar is it's wrong. Anybody just throw your microphone on and tell me, how many days of the year are there?
365 every for 3 years, and then 366 for one.
Right, which is weird, right? So the old Gregorian calendar from the 300s said that there were 365 days, but there's not 365 days in the year. There's 365.25 days in the year, which is why, as Taylor just said, every 4 years there's an extra day, because there's an extra quarter of a day. Quarter plus a quarter plus a quarter plus a quarter equals an extra full day. So we get a February 29th every 4 years. The old Gregorian calendar doesn't have that. The new calendar, the one that we use, has a leap year in it. So the math is fixed in the new calendar. The new calendar is established by Nicholas Copernicus. And Nicholas Copernicus, in 1548, publishes a book right here. 1548. Nicholas Copernicus publishes a book called On the Revolution of the Heavenly Bodies. And this, as part of the Catholic Church's Counter-Reformation, as part of their religious attempts to fix their own church, they draft a new calendar which unwittingly unleashes the scientific revolution. And this is what we're going to get into. Okay, so these things are all connected, and there's one theme I think that's gone that I keep repeating, and this is not necessarily according to Hoyle, true history, but this is the way I view history very much, is that most things in history are unintended. Most things in history, most significant, consequential things that really impact the world around us are entirely unintended. We sort of stumble upon them in good ways or bad ways. Like, look at penicillin. Penicillin was accidentally discovered. The telephone, accidentally discovered. Safety glass, like in your cars and so on, accidentally discovered. Chocolate chip cookies, accidentally discovered. All the important things in life, folks, are accidental. And this is very much the same thing with our course. A lot of the things that really are most impactful, most long-term, earth-shattering are unintended consequences. Protestant Reformation, scientific revolution, etc. So here's what we're going to do. I want to look at a philosophical argument right now to start off. Any questions on that? Like why that all makes sense, the context of this? Okay, so we're back in the middle of the 1500s again. Protestant Reformation is raging. Jan Hus has just been killed about 10 years ago with mutilation by red-hot tongs. Martin Luther has just died. He only died a few years back. Queen Elizabeth I is not yet on the throne. So right now, Edward is on the throne of England. So Henry VIII is dead. Edward's on the throne. Mary hasn't yet started all of her butchery in England. So in 1548, the scientific revolution begins. We're 40 years before the Spanish Armada. All right, just getting our heads around the chronology and the context. All right, I made a point 20 minutes ago. You probably missed this, but I made a point 20 minutes ago. And here's a key thing. The Catholic Church in the 1500s and 1400s and 1300s is not just a religious institution. The Catholic Church also controls economies, because everyone has to pay them taxes. The Catholic Church also controls the moral code of Europe. So a lot of the legal systems in Europe are based in the Judeo-Christian moral code. Catholic Church also has a real stranglehold on political decisions, political changes, because of the Holy Roman Empire, right? So all those dukes and barons and nobles and earls and marquises and so on that live in the Holy Roman Empire are under the control of both the Holy Roman Emperor and the Pope. But on top of that, the Catholic Church controls schools, and the Catholic Church is the greatest literary institution in Europe and greatest scientific body in Europe. Why? Because priests in general are scholars. They're literate. They can read and write. The vast majority of Europeans in the 1200s, 1300s, 1400s, 1500s cannot read, cannot write, cannot do mathematics. They are not educated in the traditional sense that we use education. But priests are, and the Catholic Church is. The Catholic Church has one of the greatest libraries in the world, second only to the Library of Congress in the United States, which is an incredible treasure trove for historians. If any of you go on and become historians or archaeologists or whatever, you can get access to the Vatican archives, and it is massive, absolutely massive, with all these incredible texts that are in there. It's the humanists that start translating the Greco-Roman documents, Plato, Socrates, Sophocles, etc. A lot of the humanists are priests because they can read and they can write. Martin Luther, who starts the Protestant Reformation, was a professor of theology. He was a literate scholar. So he's able to go back and read the Greek Bible. He's able to look at these concepts that are coming up and make sense of them. Vast majority of the world isn't. But here is why that matters. When Martin Luther begins his Protestant Reformation, a lot of these literate scholars break away from the Catholic Church and begin to found their own branches. So Calvin and Lutheranism, Zwingliism, and Jan Hus, etc. Now, prior to the Protestant Reformation, prior to the Scientific Revolution, there was one linear interpretation of Christianity. And that changes when we get the Protestant Reformation. And we got different interpretations of Christianity, and we have different ways of looking at God. So I want to present to you an idea here. Can I do this? I don't know if I can do that. Give me 1 sec. I'm going to have to create a Google Doc here with this because I can't share a non-Google Doc with you. 1 sec. La 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 la. Here we go. Blank. Okay, there we go. Perfect. All right. So I'm going to... There's a philosophical problem that becomes very popular in, and by popular, I don't mean, like Avengers popular. But I mean, this is a philosophical question that is bandied about quite a bit by scholars in the early 1500s. As we begin to reinterpret Christianity, as Europeans begin to analyze the Catholic Church's version of Christianity, there starts to be debate over what it actually means. So I'm going to walk you through something here, and let's present a tab. Here we go. Okay. So I'm going to present, I know. Okay. We're going to go through this, and this is the general view of the Christian faith. So let's just assume that we're all diehard Christians in 1530, 1540, and we're all looking at what it is that we believe about Christianity. Piety, which is, your faith in God, being an honest, loyal Christian. Your faith affirms the following things. Affirms means we agree on, all Christians, all of us Christians in 1500, all agree on the fact that God is perfect. This is what Christians believe in the 1500s. And this idea that God is perfect is meant to understand the following things. And there's a couple of big terms coming up here. What Christians believe is that God is omniscient, which means God knows all things. So he can read your mind and read your thoughts and read your heart and read your soul and so on. God is omniscient, and God is also omnipotent, which means that God is all-powerful. So if you believe that God is all-powerful and God is all-knowing, what that means by definition, if you take that like, omniscient plus omnipotent equals the fact that God himself is not created. Because if God is not, if God's all powerful, then nothing is more powerful than he or she is in order to create him or her. So therefore, God must be not himself created. God is eternal. There was nothing that predated God. God is eternal. God was there first. God's all powerful. God's all knowing. Okay, so if we all agree on that, if God's eternal, God was not created, that must mean, therefore, that God is the creator of all things that exist except for himself or herself. And if that's the case, that means that God is able to do anything that he or she wishes. Okay, and that's generally the accepted idea of the Old Testament God. So the Jewish God is omniscient, omnipotent, eternal, and the creator of all things. That's Christianity, Judaism, and Islam in a nutshell, right off the bat. If we add on the Christian part, the New Testament part of that, there's one other piece that's added to it, because the Old Testament God is a very brutal God, wiping out cities and turning people into pillars of salt and so on. The New Testament God, the Jesus part of the Christian God, is a bit nicer. So the additional piece to that is that God is also omnibenevolent. And omnibenevolent means that God is all good. So the Christian God is all good. That's the whole Sermon on the Mount from Jesus, turn the other cheek and love thy neighbor as thyself, and so on and so forth. So when you add in the Christian piece of it, God is omnipotent, omniscient, eternal, creator of all things, and omnibenevolent, which means that God is all good, always wants the best. Therefore, this means that God is completely just and God is infinitely loving and caring. Okay? Good so far? All right. So now, that is the Christian faith up to 1517. So I said to you, like 97% of people are Christian, Catholic in Europe. They would all accept that general idea. This has nothing to do with dogmatic interpretation. This just has to do with the belief system. But now let's overlay the Protestant Reformation, where people start to interpret religion for themselves. Okay, so God's omnipotent, omniscient, omnibenevolent, eternal, the creator of all things, and God wants the best at all times for all people. No problem yet. At the same time, what the scientific revolution begins to do, and this is again a byproduct of the humanist Renaissance, we begin to look at the scientific method, right? The idea of observation and experimentation and so on, hypothesis and thesis. This scientific method is created at the same time that the Protestant Reformation is happening. So this idea, Sir Francis Bacon comes up with the idea that there is a certain way in which we can make sense of the world around us. Prior to the Protestant Reformation, the way to make sense of the world around us was via Christianity, via the Catholic Church. Scientific revolution, building on the Protestant Reformation, says, well, we can interpret things differently than the Catholic Church does. Maybe we should do this for ourselves, which is what inspires the scientific method. Okay, so let's go back to our slide the document that we had here. Okay, so at the same time that we believe that God is omnibenevolent, omniscient, omnipotent, and wanting the best at all times for all of us, at the same time as all of that, let's layer on the scientific revolution. On top of that, our observation. So that is using our senses, sight, smell, taste, touch, etc., combined with our moral intuition, our conscience. So keep in mind that we are all sentient. We can all think for ourselves. We all have our own moral code, and yet we also interpret the world around us via our senses. If we use our physical corporeal bodies and we use our moral intuition, we are fully aware of the fact, as rational human beings, we're fully aware of the fact that the world around us is full of physical and moral evil. Well, what does that mean? What does physical and moral evil mean? What we mean by physical evil are all the things that impact human beings in the natural world. So floods and droughts and hurricanes and locusts, disease, etc. Okay? All the things, tsunamis and volcanoes going off and whatever. All the physical miseries that accompany disasters in the natural world. The world that we are living in is not the Garden of Eden. The world we are living in is a world filled with wildfires and earthquakes and flash floods and horrific natural disasters, right? That's physical evil and diseases and all the things that affect human beings. The world is also full of lots of moral evil. When we look around at our fellow people, what we realize is moral evil is abuse of people by other people. So that's murder and theft and cheating and rape and war and all the horrific things that we do to one another, all the deadly sins. That exists around us. We don't live in a world where everyone dances around rainbows, hugging bunny rabbits and singing kumbaya with each other. We live in a world filled with hatred and violence and degradation and all the misery that goes with that. So the world is full of all kinds of physical disasters, natural disasters, and human evil overlapping on top of one another. And both of those cause a tremendous amount of suffering, right? Now, that idea, okay, in view of number 10, let's go back to this. God is the creator of everything that exists except for himself. Okay, well, let's take that concept, that belief that God created everything except for himself, and put that along with number 19, which is all this moral evil. And what that tells us is that God's creation is full of a tremendous amount of evil. Now, here's the problem for the people during the scientific revolution. Let's make this a bit smaller for you. Let's compare number 20. God's creation is full of much evil. I'll make it a bit smaller. Here we go. Actually, you know what I'm going to do? I'm just going to take out 20, 11, and 14. Let's take this out. Take that out. And we'll take this out. Here is the problem of evil as defined by the early 16th century. Let's compare this. God's creation is full of much evil with the fact that God is infinitely loving and caring, with the fact that God, because he is omnipotent, omniscient, and omnibenevolent, is able to do whatever God wants. What's the problem? Here's the problem for people in the early 16th century, early 1500s, trying to logically make sense of the world around them. Why does all this physical and moral evil exist? There's a couple of explanations for it, and none of them are very good. Okay, let's go back. Here we go. There's a number of explanations for why these things happen. The world is full of lots of physical and moral evil, maybe because God can't do whatever God wants. Maybe God can't stop the wars, and maybe God can't stop the floods and the droughts and the disease, which then implies that God is not all-powerful and God can't do whatever God wants, which means maybe there's another God more powerful than the Christian God. Well, that's a terrifying thought for millions of Christians who believe that God is the most powerful entity in the universe. That's a terrifying thought, that God is not all-powerful, because maybe Satan's more powerful, or maybe another evil force is more powerful. Well, that's terrifying. Remember, Martin Luther had a nervous breakdown because he wasn't worried that he was good enough to even forgive people of their sins, let alone the fact we're all going to hell because God can't beat Satan. Good. That's terrifying for people. They can't accept that idea. So no, they got to. That can't be the reason why we have all the physical and moral evil. It can't be the fact that God can't stop it. Okay, that can't be it. All right. Well, another explanation for it, folks, is that we have all this physical and moral evil because God's not omnibenevolent. God doesn't want the best for us. God doesn't care. God isn't good. That's also terrifying, right? We don't want to believe that, because then what are we, right? This brings us back to the ideas of the way that the Greeks and the Romans viewed their gods as, using human beings as their playthings in their own little sort of snide little wars with each other, right? Zeus and Hera and so on and so forth. Well, that's not good. We don't want to believe that God is using us as simply toys to play with and then discard as he or she doesn't want. No, we have to believe that God wants the best. So it can't be that God doesn't care. We can't accept that. And it can't be that God can't fix the problems. We can't accept that either. There's got to be another explanation. And this search for an explanation that will be morally acceptable for people, and emotionally acceptable for people, and psychologically acceptable for people is really the underpinning of the scientific revolution. We are looking for an explanation other than God and the angels and so on for why things happen. If we can figure out that earthquakes happen not because God is punishing us, and not because God can't stop them, but because the tectonic plates are shifting as part of the natural world, okay. If we can make sense of the fact that floods happen because of the fact that the Earth's and the moon's gravitational pull with one another and so on, every once in a while get out of tilt because of the force of gravity, okay. If we can make sense of the fact that people die of disease, not because God is smiting entire civilizations, but because of the fact that there are microbial bacteria that exist that we can't see with the naked eye, but that are there that are causing infections that we can cure, okay, now we can still have our faith on one hand, what we believe on the one hand, but separate that out from all the things that are actually happening in the world around us. That is the quest of the scientific revolution, to find alternate explanations for all the evil in the world without blaming God. There's got to be something else at work. And what is that? The laws of nature. That's what the scientific revolution is really trying to demonstrate. Okay? Does that make sense? You can see why, especially at a time when people are extraordinarily religious. Everybody is very, very, very religious. That kind of psychological trauma is not something that people want to deal with. They don't want to think that God is toying with them. They don't want to think that God can't save them. They don't want to think of any of those things. But if we come up with a law that explains things, think about this on a microcosm kind of a way. A tragedy happens. Tragedy befalls someone. We always like to think, as human beings, we like to think that things happen for a reason, right? What we don't want to think is that we're being punished. And that's why someone gets cancer. That's why someone dies, or that's why you lose your job, or whatever it happens to be. There's got to be I mean, if economic forces based on, political decisions and economic decisions that are being made by the World Trade Organization and NAFTA are the reason why your factory got picked up and moved to a different state and now you're out of a job, that's entirely out of your control. You can still go to bed at night going, I didn't do that. I'm not being punished. Something else caused that. That's the same sort of thing we're looking at here with the scientific revolution. We're trying to find a rational explanation for why things are happening other than God, so we can keep our faith intact and yet move forward from there. And Martin Luther's Protestant Reformation allows for this to happen. Questions before we go on? No? Everybody's good? All right. I want to then, we're going to quickly sort of skim through. It's now 9:15, and I'm being cognizant again of your time. I want to spend just about half an hour, and I'm just going to introduce a couple of the key concepts in the scientific revolution. And we're going to do this through a quick PowerPoint I've got. It's only 18 slides, so it's not a huge PowerPoint. I'm going to go back to here. And by the way, I want to preface this because we're going to talk about physics here. I'm not that strong with the science, okay? Not so good with the science. I got 50% in grade 12 physics, and I got that primarily because I actually failed grade 12 physics. I only asked one question in the entire class. We were doing a unit on radiation, and the teacher mentioned gamma radiation. I was like, oh, put my hand up, and I said, you know the Incredible Hulk, could that really happen? At which point he told me not to ask any more questions ever again. I'm pretty sure I failed the course, but I got a 50 in the course because maybe because I cried, but more importantly, because he made me promise I wouldn't take any OAC or 12U sciences. And I said, and he said, okay, fine, you're passed, get out, you get your science credit. So we're going to talk about science. But I am not going to explain the actual physics of this. If you want to know how it is that Kepler actually figured out how the mathematics of the universe worked, go ask Donkers, okay? Because I don't want to mess up what Donkers is trying to do in terms of how he teaches the physics. What I'm going to talk about are the historical contexts for why these decisions are so important, why these discoveries are so important, okay? But the actual physics behind it, I am not going to explain. I'll show it to you, but I don't understand it. That really, it's not integral to our understanding of the scientific revolution. What we're looking at is how this impacts people's interpretation. Okay, so here's what we're going to do. I'm going to present entire screen. Here we go. Okay, so let's look at the scientific revolution here really quick. I'm going to open this in Google Slides because that'd be better if it opens.
Mr. Sturgio, please contact 5502. Mr. Sturgio, thank you.
Okay, so the scientific revolution. When we look at this, there are a number of key developments that impact the world around us. Remember I said that the calendar changes? Well, the universe, our understanding of the universe also changes. However, our understanding of the universe has been in existence. The human interpretation of the world around us, looking at what's available in the night sky around us, has remained constant since Aristotle. So for about 2,000 years, by the time we get to the scientific revolution in the 1500s, from about 500 BCE to about 1500 CE, the interpretation of what the universe looks like has remained the same. And Aristotle, who then gets picked up on by the Greek Ptolemy, Aristotle and Ptolemy, the Ptolemaic view of the universe, is that the Earth is at the center of the universe. Okay, so we are in the middle. Around us orbit the 6 heavenly bodies that can be seen with the naked eye. And there, if you know where to look in the night sky, if you're out, you know, in the countryside, you can't see them from downtown Cambridge because there's too much ambient light, even on a really dark night. But if you drive out into the country, so you're away from the city, and you look up into the night sky on a clear night, so there's no clouds, you can actually see the other planets, 5 of the planets, and you can see the moon and so on. So there are the following entities that we can see in the night sky. The moon orbits around the Earth. Then you've got Mercury, Venus. The sun is the 3rd big entity out, or the 4th big entity out. Then you've got Mars, then Jupiter, and then Saturn. You can see Mercury, Venus, Mars, Jupiter, and Saturn in the night sky if you know where to look on a nice clear night. Obviously, we can see the sun. Obviously, we can see the moon. The moon is closest to us. And they all orbit around us in perfect concentric circles. Why perfect concentric circles? Because for the Greeks, the circle is the perfect shape. It is eternal. There's no beginning. There's no end. It is all there. There's no wrong angles on it. A circle is the perfect shape. Ergo, the universe must exist in a perfect way. So the Earth is a perfect sphere. The moon is a perfect sphere. Mercury is a perfect sphere. We know, by the way, that the Earth is not a perfect sphere, but that's what they believed it was. So everything is spherical, and it radiates out in what are called concentric circles. Concentric means that the distance between the Earth and the moon is the same as the distance between the moon and Mercury, Mercury and Venus, Venus and the sun and Mars, Mars and Jupiter, Jupiter and Saturn. So they are equidistant from one another. Because why? Perfect circles, perfect distances between those circles. That's the way it logically would make sense. Around the outside of all that are what is called the fixed stars. So what the Greeks believed was that the stars in the night sky don't change. The moon moves, Mars moves, Saturn moves. So 1 week to another week, Saturn will be in a different place in the night sky. But the stars will always be in the exact same spot in relation to one another, which is why if you can find the Big Dipper, and I always find this fascinating, but the Big Dipper that we see is the same Big Dipper that Martin Luther King Jr. saw, which is the same Big Dipper that Martin Luther looked at when he looked up in the night sky, which is the same Big Dipper that Elizabeth I saw when she looked up in the night sky, the same Big Dipper that the historical Jesus or Julius Caesar looked up at, the same Big Dipper that Cleopatra looked up at. Essentially, they are the same because now they are fixed in the night sky according to the Greeks and the Romans. And then around that, you have got this hard shell. What the Greeks believed, Aristotle and then picked up on by Ptolemy, what the Greeks believed is that the universe is fixed. It's not growing. It's not shrinking. It is in its exact form, and it is not changing. This is a hard, like concrete wall around the outside of the universe. Outside of that is where heaven exists. So what we can physically see around us and what we can physically interact with is the human realm. Outside of that, outside of this bounded universe, is where God exists. Okay? And that's what they believed. Concentric circles, moon's closest to us, sun is the fourth planet out, fixed stars in the night sky, and so on. That's the way Aristotle viewed the universe. All that changes with Nicholas Copernicus. Copernicus begins doing math in the 1530s. Like I said, going back here. Okay. When we look at does that make sense? By the way, the Ptolemaic and the Aristotelian view of the universe. Everybody's good with that? Because it's an important concept for the vast majority of recorded human existence. For 2,000 years, that's the way people viewed the universe around us. And by the way, I know that the stars aren't fixed. So when I say that the same Big Dipper that we look at is the same Big Dipper that Elizabeth I looked at, it's actually not, because the stars are moving, but they are so far away from where we are, their movement is imperceptible to us. So the Big Dipper shape for human beings has only changed microcosmically, like microscopically, since the time of Cleopatra. So in the last 4,000 years of human existence, if you were to actually look at them in the night sky, they would look essentially the same. So the Big Dipper is the Big Dipper is the Big Dipper, although obviously the stars that make up the Big Dipper have moved, and they do move. But the distances are so vast, it doesn't look like they've moved at all. It's like when you're traveling in a car going 100 kilometers an hour down the road, and you look off in the distance at a farmhouse, you're moving, the trees that are close to you are moving, but the farmhouse looks like it's staying in one spot and you're moving around the farmhouse. Same thing. Okay, it's just that the stars are so far away, they don't look like they're moving, even though they are. So that's why the Greeks believed that stars were fixed in the night sky. They didn't change. Whereas clearly, the planets are all moving in the night sky. Copernicus, in 1538, is given a task by the Catholic Church to fix the calendar, to get people to church on time in order to pay their taxes. And on a side note, remember I said that people have to pay 10% tax to the Catholic Church. That's their tithe. At which religious event are Christians expected in the 1500s to pay their 10% tithe? Think of a big Christian event, big Christian religious event. That's when your 10% taxes are due. Gareth, nice. Easter. That's when you have to pay your taxes. So it's not Christmas. It's not the Epiphany. It's not the Ascension. It's not any of that kind of stuff. Easter. That's when you have to pay your 10% taxes. Which, again, on a little side note, and you're probably not necessarily aware of this, but your parents certainly are. When are Canadians' taxes due? In which month? Anybody? When are your taxes due?
April.
April. In what month is Easter? April.
April.
It's the same reason. That's why our taxes are due in April. Going all the way, whether you're Christian or whether you're not Christian, there are things that exist in our society today, which again, I just find is fascinating. Like why it's not a coincidence. It's because it's the way we've always done it. All right. Why do you hold your knife in your right hand and your fork in your left hand? To be polite in modern society. It stems all the way back to the Middle Ages. There's reasons for the reason why we do things. Why do we clink glasses and say the word cheers? It stems back to things we've done in the past. Same reason why your taxes are due now is because taxes for thousands of years were due to the Catholic Church in April at Easter. We don't pay the taxes now to the church anymore, but we now pay our taxes to the state, but they're due in Easter. Here's the thing. The calendar is wrong, right? 365 days, the old Gregorian calendar, not 365.25 Julian calendar. So what that means is over the course of a number of years, the calendar you're using could be off by days or weeks. And there is a little sort of loophole in the Catholic rule, which is that if you show up to pay your taxes and there's no one there to collect your taxes, you don't have to pay your taxes. So if you show up, if your calendar says Easter is on this day, but Easter is actually on a completely different day, and you show up to pay your taxes and the priest isn't there to take them, you don't have to pay your taxes. Well, the Catholic Church is losing tons of money because people are fleeing during the Protestant Reformation, because they don't want to pay the indulgences. So the Catholic Church has to get that date locked down. When is Easter? Get it locked down so everybody shows up on time. And Easter, by the way, is tied into the number of moons, number of full moons around, which is why Easter bounces week by week, year by year. Like this past year, Easter was right after the March break. Next year, there's a 4-week gap between the March break and Easter. It's because of the number of moons that we have. So Copernicus is charged with fixing the calendar and getting everyone to church on time to pay their taxes. Here's the problem. Nicholas Copernicus, let's go back and we can present this again. Nicholas Copernicus starts doing the math on this. And what he begins to realize is he can't get the math to work. Here's Nicholas Copernicus. By the way, he had some sweet Princess Leia hair going there. That's very nice. Nicholas Copernicus could not get the math to work. He's doing the 2 + 2 and it equals 5, and the 2 + 2 = 5, and the 2 + 2 = 5. He can't get the calendar to work until, for mathematical purposes, he makes a leap of logic. Let's go back. Here is the Aristotelian Ptolemaic view of the universe: Earth, Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, fixed stars, sphere of the prime mover. Copernicus, for the sake of mathematical argument, inverts 2 of these heavenly bodies, switches 2 of them. Which 2 heavenly bodies does Nicholas Copernicus flip in order to make sense of the math? Anybody? One of them is the Earth. Nicholas Copernicus flips the Earth, and which other heavenly body?
The sun.
There you go. That is exactly what he does. He changes the universe from a geocentric, Earth-centered universe to a heliocentric universe. And when he does that, when he flips the Earth and the sun, so now what we have is a sun at the center of the universe, and then Mercury, Venus, Earth, Mars, Jupiter, Saturn. That all makes sense. Well, clearly, the math works better. I don't understand the math, but anybody go talk to Hadaway. There is math behind the calendar. The math all of a sudden works. So what he realizes is that for 2,000 years, we've been saying 2 + 2 = 5. It doesn't. 2 + 2 = 4 if we make this small change. He does have one other small change. Let's go back to this one. So it looks essentially the same. The only difference is right here, right, you've got the moon orbiting the Earth. What Copernicus does is he keeps that. So the Earth has the moon orbiting it. We're the only body that has in the night sky. There's no moons around Jupiter. There's no moons around Saturn. There's no moons around Venus. There's just us. Why? Because in the religious interpretation of the time, we are special. So God gave us our own little orbiting satellite around us to remind us that we're special in God's eyes. So we have a moon just around us, but everything else revolves around the sun. Everything else stays the same. Concentric circles, right? Universe is in circles, fixed stars. A bounded universe. He keeps everything else the same. But this is how he reforms the view of the universe. This is how he reforms the calendar. And I don't understand the math, but when you do this, when you make the universe heliocentric, that's where you get the 0.25 days. That's where you get the 365.25, and the math works. The calendar now is consistent from this point forward. However, Nicholas Copernicus is terrified by the consequences of this decision, because let's put this into the context of the Protestant Reformation. Jan Hus, who reformed the city of München, Jan Hus was murdered over 3 days by Charles V for questioning the interpretation of the Christian Bible. Right? Well, not even the Bible. Questioning the Catholic Church's interpretation of how one should worship Christianity. Nicholas Copernicus is essentially saying that the book of Genesis isn't right. The book of Genesis, chapter 1, verses 1 through 7, says there was nothing, then there was light, and then God created the planets and created the sky and the land and the water and so on. The way the book of Genesis works is it goes from the macro to the micro. So at the very center of God's creation are human beings on the earth, surrounded by everything else. That's what the book of Genesis says. Well, Nicholas Copernicus is on the revolution of the heavenly bodies says, at the center is not the earth, at the center is the sun. Well, if Jan Hus can get murdered over 3 days, having his skin flayed off for questioning the Catholic Church's interpretation of religion, what is going to happen to Copernicus for questioning the Bible? He's terrified by this. So Nicholas Copernicus takes the extraordinary step, the extraordinary measure of writing a preface to On the Revolution of the Heavenly Bodies. And what this preface says is, I'm paraphrasing, in the following work, you will see some strange things. Okay, I'm going to shake some stuff up. I'm going to change a few things. This is entirely and only theoretically for mathematical purposes, just to make the calendar work. I am not saying that the universe is heliocentric, because that's crazy. That's crazy talk. We can look at the sky. The sun does that around us. Clearly, the sun's moving. We're not. We are not moving. We're at the center. God put us at the center. I know that. You know that. We all know that. Everybody knows that. But just for theoretical mathematical purposes, just for the sake of a calendar, and only theoretically, am I going to say that the sun's at the center. That's it. That's an extraordinary level of dismissiveness for a scientist to say, take all this evidence I've got and just throw that away. Because what we believe is more important than what we see. That shows how worried he was about the reaction to On the Revolution of the Heavenly Bodies. Just to make sure he doesn't get punished by the Catholic Church for what he says, because even though he's put a very, very clear on his book, he also waits until he dies to have his book published. So his report back to the Catholic Church is published posthumously, which means he's got it done. And by the way, it's done before 1543, but he's like, I am not publishing this because I am not ending up like Jan Hus or somebody. No. So he waits until he dies. And as in his will, he says, okay, now hand over my report to the Catholic Church, because they can't do anything to me now. They can't burn me at the stake now because I'm already dead. So this shows you just how worried he was by the potential consequences, religious consequences of his actions. But scientists and mathematicians are stuck-up sticky beats in many ways. If you show them an algorithm that actually works mathematically, they are not going to disregard that simply because you say, no, what we believe is this. They don't care what you believe. They only care what you can prove. And Copernicus has now proven mathematically that we have a heliocentric, not a geocentric universe. So the Catholic Church gets this book, they use it, they reform the calendar, and then they ban the book. So they say no one is allowed to read this book. This is heresy. And they put the book on the shelves. Well, the problem is people in the 1540s were just like teenagers in the 2020s. If I say to you, okay, you can do whatever you want, you just don't open this file. Okay, so here's a whole bunch of files, a whole bunch of things for you to read, but do not open this one file. Don't do it. All of you in the back of your head are being going, what's in that file? Why can't I open that file? Why? Every other file I can open up, but I can't open up that file? What's in the file? It's got to be something in the file. Maybe somebody doesn't want us to see. Maybe it's something that's really important. Maybe. And what are all of you going to do? You're all going to find a way to get into that file because I just said you can't look at that file. The Catholic Church, if the Catholic Church had said nothing, most people would disregard Copernicus's book in 1543. But the Catholic Church goes, don't read that book. So everyone's like, what's in the book? And of course, bootleg copies of the book get made because the printing press is available at this point in time. So people steal the book, make bootleg copies, and they ship them out everywhere else. And all these scientists are like, oh, have you seen what's in this book? And it starts this whole spiral of events as mathematicians and physicists are all getting excited over Copernicus's shocking revelation about a heliocentric universe. Okay, barreling forward here. Once Copernicus has done that, once he's changed the rules for how the universe actually functions, this then leads us to our next guy, who is Tycho Brahe. And Tycho Brahe is a scientist at this during the scientific revolution who spends a lot of time and is influential, not because he comes up with any formulas like Copernicus did or like Kepler does or Newton. But what Tycho Brahe does is he spends a tremendous amount of time at nighttime looking at the night sky. So he lives in Denmark. At that point in time, it was Sweden, but it's present-day Denmark because Sweden controlled the peninsula of Denmark when Tycho Brahe was alive in the late 1500s, early 1600s. And Tycho Brahe, over 20 years, spends time trying to track the stars in the night sky, trying to track the stars, trying to track the planets. And the one thing that Tycho Brahe does is he comes up with, for the very first time, verifiable data that nobody else really has, because he spent 20 years every night, sets up a plumb line, sets up this telescope type deal. It's not a telescope, but it's a plumb line. And what he does is he figures out the latitude and longitude in the night sky, the actual geolocations of Mars and Venus and Saturn and Jupiter over 20 years. And he tracks the stars in the night sky. And this is important because modern scientists rely on data, right? I don't care what you believe. Show me what you can prove. And Tycho Brahe, in that sense, is one of the first truly modern scientists saying that we need to have evidence. It's fine to believe what you want to believe, but you've got to be able to back that up. I can back it up with 20 years, volumes of data on what Mars is doing in the night sky. If you don't have that, we can't really argue. He also proved that if you take the time, and if you are lonely and sad enough, like Tycho Brahe was, you can track the planets with accuracy. So if you set up some sort of mechanism by which you can track the planets, then I can see where Mars is today and tomorrow and the next day. And the interesting thing about this is over the course of decades, sorry, folks, give me 1 second. Phone's ringing again. Give me 1 sec. Be right with you. Sorry, folks. Sorry about that. Back. Okay, this is part of the problem with being here at the school, because they know I'm here at the school, so they're asking me questions. Okay. Kepler. No. Brahe. Yes, Brahe is tracking the planets. This is really, really important concept. Really important concept. So really dial in here for a second. If you're zoning out and playing Candy Crush, zone in here for a quick second. Important concept. Not only can you track the planets with accuracy, but Tycho Brahe, because he's able to track the planets with accuracy, he can see where Mars is in the night sky today. Let's imagine that you're Tycho Brahe or I'm Tycho Brahe. I can see where Mars is in the night sky today, March or May, what is it, 18th, 2022. But I can also see where it was a year ago and 5 years ago and 10 years ago. And what's really important is that Tycho Brahe can plot this out, and he does. He puts this out on a graph. And the amazing thing about this, and I'm just going to draw you a rough diagram here. If we've got a graph, okay? So here's our graph. Can't really see that very well. Where's my black markers gone? Where's my black markers? If we graph where the planets are in the night sky, and some of them are, there you go. Some of them are more than others. But if we track them in the night sky and we actually plot them out, what we begin to realize is the planets in the night sky, let me start. If the planets are moving in concentric perfect circles, then the planets should all be at a consistent point. So we should be able to see, for whatever reason, some sort of consistency in the night sky. So we should see that in the night sky, or we should see that in the night sky, or we should see that. Some natural, consistent phenomena in the night sky is what we should see. And part of the reason why we should see that, and how do we know that there are concentric circles, and why the planets stay where they are? The Greeks didn't have any real explanation for why the planets would stay where they are, because the Greeks knew that if you take a ball and you throw that ball, the ball is going to go up in an arc and then come back down. The ball is not going to go straight, and the ball will not stay on its trajectory. There'll be a change in the trajectory. So the planets should probably not stay on their trajectory for all time, but they do. So what do the Greeks come up with? Easy. Got it all figured out because we're Greeks and we're philosophers and we got it. The planets are stuck on rings of crystal. So there are these glass rings in the night sky, crystal rings, physical crystal rings that are actually punched right through the planet's core that hold the planet like a mobile in place. So the planet rotates around on this perfect circle on this crystal sphere. Well, how are they being moved? What's the force that's moving them? Angels. Angels. Makes sense. Angels are pushing the planets at a consistent speed in a perfect circle on these concentric rings. Okay. All right. Again, here's the interesting thing. Greeks and Romans, incredible, right? The Pythagorean theorem and Sophocles, and very much ahead of their time. But at the same time that they had worked out the Pythagorean theorem, they're going, so there's angels pushing planets around on crystals? Yeah. Makes sense. Makes sense. Okay. So this is what they believe. Tycho Brahe observes over the course of 20 years, observes three phenomena, but two that are really important, that call this entire thing into question. One, if you plot Mars in the night sky, and I'm going to ballpark this for you. I actually have a graph of this, and it's not in this PowerPoint, but I could show it to you later. I'll post it for you later on. But if you plot Mars in the night sky for the Earth, looking at its latitude and longitude in the night sky over the course of 20 years, here's what Mars does. That's what Mars does in the night sky. What the hell is that? There is no consistency to that. There is no logic behind that. There's no rationality behind that. Mars is all over the friggin' night sky. All over the night sky. That does not match what Copernicus said, or Ptolemy, or Aristotle, that they're on concentric circles. And there's nothing about that that actually makes any logical sense. And Brahe doesn't know why it does that. He just says, I can prove that Mars is all over the night sky. It's not in a consistent, coherent, logical path. I don't know why, but it's not. What else does he discover? To his horror, absolute shock and horror, he sees a comet one night. And mathematician that he is, sees a comet one night, sees a comet the next night, sees a comet the next night, sees a comet the next night. He begins to plot out the comet's path. And he realizes with his absolute abject horror that that comet is about to pass right through one of Saturn's rings. Right through it. And I don't know about you, but if you've ever been dumb enough as a kid to throw something hard anywhere near a window and then broken that window, and then your parents were unhappy about the window, a comet going through a crystal sphere is going to break that sphere. And then that means Saturn is going to go shooting off, which means we're not going to have Saturn anymore, which means I don't know what the hell, but it's just terrifying. And he sits there and he watches, he's like, oh my God, you're a comet, oh my God. And the comet passes right through the sphere. And the next night he watches and the comet's moved on and Saturn's moved on and comets moved on and Saturn's moved on and comets moved on and Saturn moved on and nothing changed. The comet literally passed right through where that crystal, where that glass pane should be, with no impact. Well, that either means that comets are not made of physical corporeal form, or the crystal spheres don't exist, or something just happened. But I don't know what it is, but something just happened. That's bizarre. So again, what Brahe's big contribution is, folks, is not that he actually works out the math like Copernicus does or Kepler does, but he observes phenomena that he can back up with his data that doesn't make any sense. So faith, this is number 3 here, faith is no longer a valid argument for why things happen. We can't say it's angels and crystal spheres and God and so on and so forth, because that doesn't explain Mars. That doesn't explain, number 5 here, the comet moving right through the planetary path, which means there can't either, the heavenly bodies are not corporeal, or there are no crystal spheres, which means there's no angels, which means there's something else that's causing the planets to stay where they are and causing the planets to move. He also one night observes, and this is a thing that also really freaks him out. Remember, everyone talks about the fact that the stars in the night sky are permanent. Well, Tycho Brahe sees a new star one day. He's been watching the night sky for 16 years. That star was not there, and he sees it. And over the course of the next several months, he sees this star, and it's a brand new star that was not there before, and it gets brighter and brighter and brighter. He's like, I'm watching a new star being born. That's not even possible. And then, even more impossible, one night the star vanishes and never reappears again. Tycho Brahe has no idea what's just happened, but he's just seen a star born and a star go away. What do we now know? If we see a star in the night sky that didn't exist, that all of a sudden becomes really bright and then ceases to exist, what do we call that? Anybody?
Would that have been a supernova?
Exactly. So he saw a star explode somewhere off, billions of miles away. But if stars can die, be born or die, then that means that the stars in the night sky are not fixed the way that Copernicus and Aristotle and Ptolemy believed, which means that there's, again, something different. Tycho Brahe's big contribution, folks, is he is the first true modern scientist that looks at data and says, we got to use the data to drive our beliefs. I don't care what you believe. What does the data tell you? All right. Now, His biggest final contribution is the fact he's not a strong mathematician. So he hires a guy to work out the math for him, why Mars is doing that. And the guy he hires is Johann Kepler. Johann Kepler works out three big things working on the math from the Mars document. Here's one page out of one of the ledgers of Johann Kepler's mathematics. And the thing I find absolutely staggering about these individuals, and I mean this with all sincerity, there's no calculators. There's no supercomputers crunching the numbers on this. Johann Kepler sat down, look at the math, look at the number of numbers in the formula he's trying to work out to figure out what the actual orbits of the planets are and why Mars is bouncing all over the night sky. We're talking serious genius level material here with Johann Kepler. Johann Kepler, and in the video I'm going to link for you to watch this afternoon, there's a really cool explanation of how Kepler actually comes up with this, so I'm going to leave it for the documentary to show you. But Kepler comes up with three big discoveries, okay? Three big discoveries. First of all, he realizes in his mathematics that the planets don't move in circles. Part of the reason why Mars does this is because the planets move in ellipses rather than in circles, right? It's like an egg rather than a tennis ball. That changes a tremendous amount in terms of our observation point vis-a-vis the sun, the moon, the stars, etc. On top of that, what he argues is that the sun is not at the center. Copernicus was kind of right by saying heliocentric, but the sun is actually off-centered. The sun is at one of the two foci of the ellipse. On top of that, he argues that the planets sweep out an equal distance in time. So there is a consistency to it. All right? So when we look at the overall area of this triangle, and the overall area of this triangle, the actual area is the same. And the documentary I'm going to show you does a much better job on this than I do. Which means that when we look at the outer part of the orbit, this looks like it's going further than here. But the overall area is actually the same. So that means that there is a consistency. There's an equal area and equal time that the planet is moving in the night sky. Again, works all this mathematics out on his own. Finally, he comes up with this beautiful little piece of work, easy peasy mathematical formula, which is the ratio of the squares of the orbital period for two planets is equal to the ratio of the cubes of the radii of their orbits, which means planets have different orbits and longer years than we do. And it also means if you know the orbital period for two of the planets, you can figure out the orbital period for all the planets. Well, we know one, 365.25 days. Kepler, in his book on the motion of Mars, published 1609, figures out Mars. Once he's got Earth and Mars, now he can figure out what's Mercury's orbit, what's Venus's orbit, what's Saturn's orbit, what's Jupiter's orbit. And he's absolutely right. Okay, 1609, no calculators, on his own, with parchment, ink, quill. He figures it out by himself. Incredible, incredible, incredible changes. Okay. There's two more that come after this, but in the interest of time, I'm going to stop also because the documentary does a really good job with the last two. So the last two, I'm just going to show you really quick. Galileo is really, really important because he starts the march towards Sir Isaac Newton's ideas with a number of experiments that he does, working on gravity, working with the telescope, and so on. The documentary is going to get into that in some really, really good detail. And then, of course, most importantly, is that Sir Isaac Newton, who also looks like the guitar player from Queen, Sir Isaac Newton is going to come along and write the most important scientific work, arguably of all time. 1689, he publishes a book called the Principia. And in the Principia, you've got the three laws of motion. Body at rest stays at rest unless acted upon by external force, right? And so on. He works on force equals mass times acceleration. Three laws of motion and the law of gravity is what he works out in the Principia. These last two guys, Galileo and Sir Isaac Newton, bring together the ideas of Kepler and Brahe and Copernicus and Ptolemy and all these earlier individuals, brings them all together in a way that makes sense for all of us moving forward. And really, when asked, and we talk about polls and so on, I like polls when people, poll various people in the past. The There was a poll recently done in 2011, 2012, the world's leading physicists of what is the most important scientific discovery of all time, or most important scientific work of all time. Hands down, Sir Isaac Newton's The Principia was the most important scientific work ever written in physics, according to all these modern scientists. More important than Einstein's theory of relativity, more important than anything Stephen Hawking ever did, more important than any of the greatest minds since the late 1600s. Sir Isaac Newton's The Principia, the most important document. Okay? All right. Long morning. Sorry, long morning. That was a bit longer than I wanted. But here's what I'm going to have you do. I'm going to post for you right now okay. So I'm going to post for you this documentary, and edit, here we go. All right, this documentary is by a guy named James Burke, and James Burke is just awesome. He's British, and he's got this very dry sense of humor and so on and so forth. So I'm going to post this for you right now. Wait 1 second. Cancel. And this documentary is called The Day the Universe Changed. And it's 44 minutes long. And what James Burke does is he takes some of the ideas that we already talked about with Brahe and Copernicus, and he actually goes to Copernicus's lab, and you see Copernicus's big physical machine that he built to try and understand the universe. But then he goes through and looks at Galileo and Newton in and Kepler, Galileo, and Newton in great detail, but in a really entertaining kind of British way, and explains how these individuals were able to make sense of the world around them for all of us moving forward and getting away from a religious interpretation of the world into a scientific interpretation of the world. So we're moving away from the religious and into the secular. Here is your task for the rest of the day, at your own pace, at your own time. 1, watch the documentary. It's 44 minutes. It's very, very good. It's really good because it explains the whole, like, how do they figure this stuff out? Like, I'm just astounded by what these guys were able to do. Do that, and then the remainder of the day is time for you to work on your Elizabeth essay, if you haven't got that done yet, or your Louis XIV, Peter the Great comparative task, which is due today. All right, so that's your task for the remainder of the day. I'm going to let you folks go. If you have any questions today, I won't have an optional meet this afternoon, but if you have any questions, send me an email and I will jump right on the email. I'll jump right back to you and respond to your questions. I can also set up individual meets with you if you have any questions, you want to go through certain things. But the rest of the day is yours. 1, watch the documentary. 2, work on one of those 2 written assignments, Louis XIV versus Peter the Great or Elizabeth. Questions? Goodbye, folks. Have a great day.
So you were talking about like their understanding of the religion.